Hey everyone! Welcome back to our channel. I'm so glad you're here today because we're diving into a really interesting topic that's becoming more and more important in the world of data science and machine learning. Have you ever wondered how we can tell if our machine learning models are still performing well after they've been deployed? Well, today we're talking about drift detection in deployed models. So, let's get started. But first, let me ask you a question. How do we know if our models are still reliable once they're in the real world? What happens when the data they were trained on starts to change? This is where drift detection comes in. Drift detection refers to the process of identifying changes in the statistical properties of the input data or the model's predictions over time. These changes can negatively impact the model's performance, leading to less accurate predictions. There are two main types of drift we should be aware of: covariate drift and concept drift. Let's start with covariate drift. This occurs when the distribution of the input features changes. For instance, imagine you've built a model to predict house prices based on features like size, location, and number of bedrooms. If, over time, the housing market shifts to include more eco-friendly homes with different features, the model may struggle because it hasn't learned from this new type of data. Next up is concept drift. This happens when the relationship between the input data and the target variable changes. Using the same house price model example, let's say that a new trend emerges where buyers favor smaller homes or homes with smart technology over larger ones. Even if your model's input data remains the same, the underlying relationship between features and prices has shifted, leading to inaccuracies. So, how do we detect these drifts? There are a few common techniques that data scientists use. One popular method is statistical tests. For covariate drift, we can use tests like the Kolmogorov-Smirnov test or the chi-squared test to compare the distributions of the training data and the new incoming data. If there's a significant difference, that's a red flag. For concept drift, we can track the model's prediction performance over time. If we notice a consistent drop in accuracy, it could indicate that the underlying data relationships have changed. Additionally, techniques like monitoring the prediction error can help us identify when a model is beginning to drift. Let's look at some real-world examples. In the finance sector, companies use drift detection to monitor credit scoring models. If a model starts predicting defaults inaccurately due to changes in the economy, it can lead to significant financial losses. By implementing drift detection, companies can retrain their models with the latest data, ensuring they remain accurate and reliable. Similarly, in healthcare, machine learning models are used for predicting patient outcomes. If a model was trained on data from a specific population, but the demographics shift over time, the predictions may no longer be valid. Drift detection helps healthcare providers identify when to update their models, improving patient care and outcomes. Now, you might be wondering, how often should we check for drift? Well, it really depends on the domain and how quickly things change. In fast-paced environments, like finance or e-commerce, it might be necessary to monitor for drift daily or weekly. In more stable fields, like agriculture, quarterly checks might be sufficient. Today, we've learned that drift detection is essential for maintaining the reliability of deployed machine learning models. By understanding and monitoring for covariate and concept drift, we can ensure our models continue to perform well in the real world. If you found this video helpful, please give it a thumbs up and share it with your friends. Don't forget to subscribe for more educational content and leave a comment below about your experiences with drift detection. Until next time, keep learning and exploring the world of data science.